Hello everyone, welcome to my new video in my Mathematics Essentials series. I will continue proving trigonometric identities, and in this video I will prove identities 14 through to 17, which are known as the double angle formulae. Double angle formulae. And that's just because you're taking the sine or the cosine of some angle that is being doubled. Okay, so I will just highlight the ones that I'm proving. Okay, and it turns out that once we prove some of these, then we can prove the others, etc., etc. It's a bit of a rolling on effect. Okay, so it's nice. And we will also make use of the Pythagorean identity in some of these proofs. Okay? All right, let's get started. So we will prove trigonometric identity 14 first. The sine of 2 theta equals 2 times the sine of theta times the cosine of theta. Okay, so let's write out what we are proving. The sine of some angle that's been doubled equals 2 times the sine of theta times the cosine of theta. And we will also make use of the sum formulae as well. Okay, we'll make use of those. Trigonometric identities 10 and 11. All right, so let's start the proof. Okay. Now the sine of 2 theta equals, well, we can re-express the argument of sine as a sum. So it equals the sine of theta plus theta. And once we do that, we justify using the sum formulae. Okay, so the sine of the sum of two angles is equal to the sine of the first angle, which is theta, times the cosine of the second angle, which is theta, plus the cosine of the first angle, which is theta, times the sine of the second angle, which is also theta. Okay, and you can see that both of these terms are really the same term. Okay, this term is like a times b, and this term is like b times a. Okay, so they are equal. So we really have the same thing plus the same thing. Okay, so we can really write this as 2 times the sine of theta times the cosine of theta. Right, and that's precisely what the identity says, so that completes the proof. Okay, now let's move on and prove this one here. Okay, trigonometric identity number 15. Okay, so identity 15 says that the cosine of 2 theta, which is just some angle that's been doubled, equals, okay, the cosine squared of theta minus the sine squared of theta. I'll just double check that I've got that right. Cosine squared of theta minus sine squared of theta. Yep, that's correct. Okay, let's prove it. Okay, this will be similar. Okay, the cosine of 2 theta we can express as the cosine of theta plus theta, all right, which justifies applying the sum formula. And the sum formula for cosine, or the sum formula for cosine, is the cosine of the first angle times the cosine of the second angle, which is also theta, minus the sine of the first angle times the sine of the second angle, which is also theta. Okay, so we have the same thing times the same thing, and similarly over here, so these factors, or these terms, are really squares. So this is the cosine squared of theta, and the other term is the sine squared of theta, and that's precisely what the identity says. Okay, so this completes the proof. All right, now let's move on and prove trigonometric identity 16, which says that the cosine of 2 theta is equal to 2 times the cosine of theta squared minus 1. Okay, let's write that down. The cosine of 2 theta is equal to, I believe it was 2 times the cosine of theta squared minus 1. That's how short my memory is. But yes, I recognize this, so no need to double check. Now, we will apply the Pythagorean identity here. Okay, so we'll start the proof. Okay, by the Pythagorean identity, should be a capital P, by the Pythagorean identity, which is identity 3 in our list of 19. Okay, we have that the sine squared of theta plus the cosine squared of theta equals 1. Okay, now what we can do is rearrange this expression, or this equation, so that the sine of theta squared is the subject. So to do that, we just subtract the cosine of theta squared from both sides, and we have that the sine of theta squared equals 1 minus the cosine of theta squared. All right, and by the last identity we proved, okay, which was, what was it? It was identity 15, okay? And by identity 15, we also have that the cosine of theta, or of 2 theta, sorry, the cosine of theta doubled is equal to the cosine of theta squared minus the sine of theta squared. Okay, but we can replace this sine of theta squared term with this expression here because it's equal to the sine of theta squared. So if we do that, we obtain is equal to the cosine of theta squared minus, in brackets, 1 minus the cosine squared of theta. Now we just distribute the negative sign. Okay, so we have that the cosine squared of theta minus 1, or this is equal to the cosine of theta squared minus 1 plus the cosine of theta squared. All right, and now we just collect like terms, and we have 2 times the cosine of theta squared minus 1, which is what the identity says. Okay, I'll just show you. Okay, that's what we wanted to prove. All right, so moving on, all that's left to prove is identity 17 in this video. The cosine of 2 theta equals 1 minus 2 times the sine squared of theta. So let's do that. Okay, the cosine of 2 theta equals 1 minus 2 times the sine of theta squared. All right, let's start the proof for this one. Okay, now we are going to do the same thing, okay, that we did in the previous proof, but instead of rearranging for the sine of theta squared, we will rearrange for the cosine of theta squared. So if we do that in the Pythagorean identity, so we'll say the Pythagorean identity implies, well, if we take the Pythagorean identity and rearrange it for the cosine of theta squared, okay, we get 1 minus the sine of theta squared. Okay, that's just taking the Pythagorean identity and subtracting the sine of theta squared from both sides. Okay, now from the last identity we proved, which was 16, I think, in our list, yeah, 16. Okay, so from trigonometric identity 16, from identity 16, we have that the cosine of 2 theta is equal to no, we're not using 16. We are using 15. Okay, so from 15, we have that this is equal to the cosine of theta squared minus the sine of theta squared. All right, now we can just make the substitution here for the cosine of theta squared. All right, and if we do that, we obtain, okay, 1 minus the sine of theta squared minus the sine of theta squared. Now the brackets here are really doing nothing. I just wrote them in to show the substitution. So this is really 1 minus something minus the same thing. So collecting like terms is 1 minus 2 times the sine of theta squared, and that's what the identity says. So this completes the proof. Okay, so let's go back up to our list and cross off everything that we've proven. So in this video we proved 14, 15, 16, and 17. So that's 17 identities down in total, and that just leaves 2 to go.